Hi everyone, welcome to Mathworld. This is Cambridge International AS and A-Level Further Mathematics, Paper 2 for October-November 2022. The code is 9231/22. So this is a part 3 of this whole paper. Therefore, I'm going to discuss question 5 and 6. Okay, so let's move on to question 5. Now, write down the fourth root of unity. So, fourth root means you are solving z degree 4. The unity means 1. Okay, so when you need to solve this, basically, you move the degree 4 to the right side, or no. We will start with degree 2 first. Okay, you slowly decrease the degree. So, when you keep the degree 2, means that you are moving the degree 2 to the right side. It will be plus minus square root 1, which is 1. Okay, so from here, to get the z, it will be plus minus square root 1 and plus minus square root negative 1. All right, hence you are getting four values, or what we call as 4 roots. It will be plus minus 1 and plus minus I, because square root minus 1 is I. All right, so let's move on to part B. So now, use the Moivre's theorem to show that cos 4 theta equals to 8 cos degree 4 theta minus 8 cos squared theta plus 1. So this is what you need to show. Now, according to the Moivre's theorem, we must start with cos theta plus I sin theta. Now, due to the 4 theta on the left-hand side, right, cos 4 theta, therefore the degree for this expansion must be 4. Now, according to the binomial theorem in the formula list, so it will be cos theta degree 4 plus 4, 1, cos theta degree 3, then I sin theta degree 1. Okay. Then plus 4, 2. 4, 2. This is called 4C2. The combination. Cos theta degree 2, I sin theta degree 2, then for 3 cos theta degree 3, degree 1, because the first term degree must be dropping. So I sin theta degree 3 plus I sin theta degree 4. Okay, so from here, right, now left-hand side, according to de Moivre's theorem, you will bring down the 4. So it will be the multiple of the theta. Now for the right-hand side, you need to simplify. So first term, cos degree 4 theta. Then 4C1 is 4 cos degree 3 theta times I sin theta. After that, 4C2 is 6 cos squared theta. Then multiply by I squared sin squared theta. Okay. Then followed by 4C3, which is 4. So I get cos theta multiplied by I cube sin cube theta. And lastly, I will get I degree 4 sin degree 4 theta. This will be the binomial expansion. Now, okay, you need to simplify. I squared is basically minus 1. So now for the right hand side, cos degree 4 theta plus, I may factorize I first. So 4 cos cube theta sin theta plus the I squared is minus 1. So minus 1 times plus 6, it will be minus 6. So minus 6 cos squared theta sin squared theta. Okay, now I cube is I squared times I, which is minus 1 times I, then you'll be getting minus I. So I will get minus I 4 cos theta sin cube. Okay, and then I degree 4 is square of I squared, which is square of minus 1. And at last, we will be getting 1 for the I degree 4. So here, I will get plus sin degree 4 theta. Okay, so now, since we are showing cos 4 theta, so we will just refer to the real part of this expansion. So now, cos 4 theta real parts will be cos degree 4 theta. First term, third term is -6 cos squared theta, sine squared theta, and the last term. Okay, so now this is the expression for cos 4 theta, but when you refer to the question here, we have to change the sign to cos because in the question it just has cos, right? Cos theta in terms of cos theta instead of combination of cos and sine. So now we need to simplify or convert the sine squared theta into cos squared by using this identity. Cos squared theta plus sine squared theta is 1. Therefore, sine squared theta is 1 minus cos squared theta. So here, cos degree 4 theta minus 6 cos squared theta multiplied by 1 minus cos squared theta plus the sine degree 4 theta is 1 minus cos squared theta, then another square, because it is square of sine squared theta. So now, just do the expansion. So minus 6 cos squared theta times 1, it will be minus 6 cos squared theta. But then when multiplied by negative cos squared theta, it becomes plus 6 cos degree 4 theta. Now, for the last term, square of 1 minus cos squared theta, we have to do expansion. So plus 1 minus 2 cos squared theta, then plus cos degree 4 theta. Okay, so now simplify. The first term, cos degree 4 theta. Third term, also cos degree 4 theta, but it is 6. Then last term, also cos degree 4 theta. So when you get the total of these 3 terms, it will be 8. Okay, therefore the cos squared, now second term and the 1, 2, 3, 4, 5, in the fifth term. Okay, so minus 6 minus 2, it will be minus 8 cos squared theta. And the only constant here is plus 1. So this is how we prove or show the expression for cos 4 theta in terms of cos theta using the Moivre's theorem. Okay, so with this, we have done the part B. All right, so now let's move on to part C. So hence is the keyword, okay? Because hence means use the previous answer to solve the part C. So obtain the real roots of the equation. So your equation is 16 times 8x degree 4 minus 8x squared plus 1, the whole term to the power of 4 minus 9 equals to 0. So the roots here is basically the x, okay? Because that is the only variable in the equation. Now you have to find the x in the form cos q theta, cos q pi, where the q is a rational number. So now, when you refer back to the previous question, because of this word hence, right? So now, just now we have proven that cos 4 theta in terms of cos theta. But the first term, degree of cos theta is 4. Second term is 2. All right? So that means this is similar to the terms inside the brackets here. Degree 4, degree 2, and 1. So I will write from B cos 4 theta equals to 8 cos degree 4 theta minus 8 cos degree 2 theta plus 1. So now when you need to write the equation, right, and you compare these two equations right now, I will say that my x is basically the cos theta. So let x equals to cos theta. And this is the reason your root, which is the x, will be in terms of cos. Okay, cos q pi. This is how we get the cos theta over here. So I will get 16. This whole bracket will be cos 4 theta. So cos 4 theta degree 4 minus 9 equals to 0. So now cos 4 theta degree 4 will be 9 over 16. So we get the cos 4 theta squared first. It will be plus minus square root 9 over 16, which is plus minus 3 over 4. But you know that squared cannot be minus. Therefore, cos 4 theta squared is basically just 3 over 4. Now, with this, we need to get x, okay? X is cos theta. So, therefore, you need to calculate the theta first. Find out the theta values. So, now, move the square to the other side by taking plus minus square root. So, you'll be getting plus minus square root 3 over 2 for the cos 4 theta. So, for the cos 4 theta, since this is plus minus, means that you have to consider all 4 quadrants. So, when you use calculator, the principal value is pi over 6. Alright, then the next one is 5 over 6 pi. So, since this is 4 theta, means that you have to consider the initial cycle and plus 3 more cycles. Okay, so from here, I will say 4 theta is basically plus minus pi over 6 plus 2k pi. We use plus 2k pi here is because of for the cos theta, the graph, okay, it is repeating for every 2 pi units. That's why we consider the next cycle, it will be 4 pi. So I will consider one cycle is 2 pi, then the k is up to is depending on the 4 theta here. So it means that your k will be from 0 until 3. Okay, and another value will be plus minus 5 over 6 pi, then plus 2k pi. So now, your theta will be plus minus pi over 24 by dividing the pi over 6 with 4, okay? And then the 2k pi divided by 4, it will be k pi over 2. And the next one will be plus minus 5 over 6 pi, 5 over 24, because 4 times 6. And then plus k pi over 2. So you replace the k by 0, 1, 2, 3. Okay, then at last, my x equals to cos theta, which is cos pi over 24. Okay, cos 5 over 24 pi. So I get this value when the k equals to 0. So then you continue with k equals to 1, 2, and 3. So you will be getting all these solutions. Okay, so these are the solutions for question C. Okay. All right, so let's move on to next question, number 6. So for question 6, you are given a graph. Okay, graph y equals to 1 over square root x squared plus 2x. So this is y equals to 1 over square root x squared plus 2x, where the x more than 0 together with the set of n minus 1 rectangles. So when you look at here, this is the first triangle. Okay, first triangle. This is a second triangle. So the last triangle, by referring to the first ordinate, it is n minus 1. Therefore, n minus 1 rectangles of unit width. Unit width means that the width is 1. So here, always 1. All right. So now, by considering the sum of the areas of these rectangles, so we need to get the sum of the areas of the rectangles, show that summation r from 1 until n, 1 over square root r squared plus 2r. So this is similar to the graph equation. Is less than ln n plus 1 plus square root n squared plus 2n plus root 3 over 3 minus ln 2 plus square root 3. Okay, we need to show this. Now, firstly, we need to consider sum of the areas of the triangles. So the areas of triangles is basically width times height. Okay, so the height here, we have two ordinates to form one rectangle. So 1 and 2 for the x values. But then the height is not referring to the y value when the x is 1, but referring to the x equals to 2, the y value when x equals to 2, right? So you have to take note on this. So now what I need to do here is I will write sum of the areas of triangles equals to width times height. So the width is 1, okay? The height is referring to the second ordinate of each rectangle and not the first, right? So the second ordinate of the first triangle is 2. So it will be 1 over square root 2 square plus 2 times 2. This is my first height. Second triangle, the height is referring to the y value when x equals to 3. Okay, so now again, replace the x by 3 over here. So I will get 1 over square root 3 square plus 2 times 3 plus until 1 over square root. Okay, so second ordinate of the triangle is n. So replace the x by n. I will get n squared plus 2n. Alright, so from here, due to the sum, I will change to, due to the plus, I will change to sigma or summation. So all of these terms are following the last form, whereby I can change the n to r because I need to get the left-hand side in the inequality. So it will be r squared plus 2r. Now, my r starts from 1. Oh, sorry, my r starts from 2 because when you compare this, okay, 2 squared, r squared. So 2 bracket 2, that means your r is 2. Initial r is 2, okay? And then the last r is n. This is our sum. But now if you refer to the inequality that we are going to show, your r starts from 1. So it means that later we need to change to r starts from 1 instead of r equals to 2. Okay, how do we get this right-hand side? Now, this right-hand side is basically the area under the curve because we know that, okay, the area under the curve is more than the sum of the rectangles, right? Or I would say that the sum of the rectangles will be less than the area of the curve. Okay, so now to get area of the curve, we need to do integration. So integrate your area starts from 1. See, the x is 1 over here until n, right? So 1 until n, the graph y dx. Okay, so now when you need to solve this integration, since there is a square root in the denominator, we need to complete the square. So to complete the square, I will rewrite first two terms, then plus square of the bracket and minus square of bracket. So the terms inside the square and inside the bracket, it should be the half of the coefficient for x. So here I will write 2 over 2, 2 over 2. So now when I simplify, I will get x plus, now 2 over 2 in this bracket, it will be 1. Okay, then minus 1 squared dx. So basically, we are solving this equation, this integration. Now, by referring to the formula list, okay, you were given this formula. Square root, integrate 1 over square root of x squared minus x squared dx. It will be arc cos of x over a plus c. Okay, and now when you refer to the answer here, there's a ln. Therefore, we need to get the cosh expression. Okay, cosh x is basically ln of x plus square root x squared minus 1. So we may need to use this in the later working. So now, from here, okay, so when you check, this is x squared, this is x plus 1 squared. Again, use the substitution method. Let u equals to x plus 1, so that it will be just variable squared. So du over dx is 1. Therefore, du is dx. Now, you may change the x values, okay, from 1 and n to the u. So when x equals to 1, your u will be n plus 1. Okay, and then when x equals to n, so your u will be, oh sorry, mistake here. When x equals to 1, okay, when x equals to 1, your u is 2. All right. So when x equals to n, it will be n plus 1. So now I will change the limits. So instead of 1 to n, it will be 2 to n plus 1. So 1 over square root u square minus 1 square. The dx will be du. Okay, so now it's exactly the same as the formula in the formula list. It's just that now you need to change your x to u. Okay, so which means I will be getting cosh u over a. So my a is 1, therefore just inverse cosh. Sorry, it's at cosh. Okay, at cosh u. Then the limit from 2 to n plus 1. Okay, so now replace. So for the inverse cosh, right, at cosh u, I will be, if you just replace directly, right, so later on you need to change to this form as well. Apply the properties, the formula, the definition for inverse cosh, because our final answer will be in terms of ln. So now, first of all, you replace it by inverse cosh. Your u is n plus 1. Then minus inverse cosh 2. So now for each inverse cosh, replace it by ln. So I will get ln. Now your x here becomes n plus 1. So replace the x by n plus 1 plus square root n plus 1 squared minus 1 according to here. Okay, then minus ln. Now my x becomes 2. So I will get 2 plus square root 2 squared minus 1. So when you simplify, it will be ln n plus 1 plus square root n plus 1 squared minus 1, then minus ln 2 plus square root 3. Okay, so let's look at the answer first, the given answer. Now you have n plus 1 plus square root of 2 terms, n squared plus 2n. Okay, and minus ln 2 plus ln 3. So here I'm getting minus ln 2 plus square root 3, and then this one is not acceptable because of the square. Now we have to do expansion. So do the quadratic expansion, n squared plus 2 plus 2n, then plus 1 minus 1, then minus ln 2 plus root 3. Okay, therefore ln n plus 1 plus square root n squared plus 2n minus ln 2 plus root 3. Okay, so now when you compare to the given answer, so basically we have found the first and third term, not the second term. So I need to get second term. Don't forget, right? Just now we have found the sum, but this sum, initial r is 2. And now we need to prove the initial r is 1. So this is the actual sum. Okay, so from here, we know that this is the actual sum. Actual sum is basically less than the area of the curve, right? Because you still have this extra part. All these are not counted. So I may start with the actual sum. less than the integration, less than the area under the curve. Okay, so from here, if I start the sum whereby the r equals to 1 until n, okay, I will get this. And then I plus with summation, because I have considered r from 1 until n instead of r from 2. So that's why I have to replace the r by 1. So here r from 2 until n, 1 over square root r squared plus 2r. Now, first term, it will be 1 over square root 3. Okay, then here, it will be plus this summation. We know that it is less than, okay, this summation is less than the integration, which means it's less than this. So when this term is less than the integration, which means here I cannot write equal sign anymore. I should write less. Okay, and then this whole integration, less than the integration. Therefore, you have to rewrite the other two terms. Okay, and then now let's compare with the given answer. So first term is ln, second term is root 3, 1 over 3 root 3, third term is another ln. So now, by looking at our answer right now, it's better for you to rewrite. Okay, first term is the ln. Now, second term, instead of writing 1 over root 3, you may write 1 over 3 times root 3, which is the same. So minus ln of 2 plus root 3. So this is how we show this inequality. Okay, we are using the concept, the area under the curve is less than the total sum, the total area of the triangles, because we still have all these extra parts here, okay, that are not considered in the rectangle. Okay, so that's all for this video. All right, so again, if you like my videos, don't forget to subscribe to my channel and stay tuned for the upcoming videos for the solutions of the remaining questions. Okay, thank you. Bye.